Good day, viewers. This presentation video covers an emerging technology group project on the development of a new biomaterial. This project was conducted by Malibongwe Sukaya, Abongile Nkosiapansi, Nicolaas Jacobus Richter, Sheldon K. John Rousseau, Gawie Oosthuizen van Wyk, and Marcel Stevens. This presentation is divided into 5 themes. Firstly, the research phase, where a new biomaterial solution and the possible adaptation thereof was investigated. Secondly, the investigation of materials that could be introduced to develop this biomaterial. Thirdly, designing an application for the new biomaterial. Fourth, evaluating the biomaterial's properties. And fifth, delivering the conclusion to the project.
We chose to focus on coconut husks, the fibrous outer shell of the coconut fruit. They are composed of approximately 30% fiber and 70% pith, which makes them a valuable and versatile material. It has elastic, durable, and rot-resistant characteristics, making it ideal for use in a variety of applications such as producing coir. Coir is used to make ropes, carpets, and even brushes. If we look at a material such as composite board, it is typically made using non-degradable materials that can prove to be harmful to the environment. Coconut husks, on the other hand, are a natural and sustainable material that can be used to create boards that are just as strong and durable as composite boards, but without the negative environmental impacts. We also looked at coffee grounds, which is a highly versatile material that is overlooked and discarded on a daily basis. One of the most notable characteristics of coffee grounds is its high mineral content, consisting of calcium, potassium, and iron, just to name a few. We found that these minerals typically help promote plant growth when used correctly. In addition to its nutrient content, the coffee grounds also have the ability to repel insects and pests. This is because the coffee grounds have a very strong scent that proves to be repellent and potent to many types of insects. This makes it an excellent natural alternative to chemical insecticides that can be harmful to the environment and to our health. Another benefit of using coffee grounds is its ability to neutralize odors. Coffee grounds have a natural deodorizing effect, which makes it a useful material for absorbing unpleasant smells in areas such as the kitchen or the bathroom. From there, we looked at bioresin, a waterproof plastic alternative that acts as a filler material. We found that this resin is food safe, organic, and would have a smaller impact on the environment thanks to its biodegradable characteristics.
To start off our reference boards, we started with a form study board. So our form study board compiled a lot of natural, more organic shaped forms that directly influenced our end product. In the middle on the right is a vase that has a particular wave pattern on it that we took directly to the final product. For the next board, there was a lot of interesting patterns and details that we wanted to incorporate within our final product. This mainly turned out to be a wave pattern and a dotted pattern. As you can see in our second board here, that the wave pattern is as well very present in it. We definitely thought about taking this to the final product, as it will create a lot of interesting shapes to be able to play around with the cup, with creating certain grip for the hand. On our third reference board, at the top on the left, we can see a circular pattern indented into a vase. We thought about incorporating this pattern as well, as we saw it very intriguing, that we could place this pattern in the position of the user's palm. So when the user picks up the cup, it will allow airflow in between the palm of the hand and the cup as well, basically diffusing that heat coming through the cup to the user's hand. This will probably make the drinking process of coffee more enjoyable, as you're not holding a scalding hot cup anymore. On the fourth board, we have a unique arrangement of different style design cups. They all have different attributes, from shape to glaze to the handle themselves, but we didn't really take much influence from this board. We took influence from the top right corner, and we took that more fluid organic shape along to our final product. Though we did not see fit to actually put a handle in our final product, as we already had the circular indent texture that diffuses the heat, so there was no need for an actual handle in the end product.
After examining the reference boards, we moved on to the scamping process. We started by doing a form study, consisting of random shapes and objects. The shapes leaned more towards an organic appearance, therefore we focused on building from that. Other boards explored options like coffee cup holders, an actual coffee cup, as well as different vases, also featuring iterations of these ideas that investigated key factors that would affect users' experience, ultimately deciding on a coffee cup for the final product. The design is simple and modern, allowing the material to be the main selling point. The cup has interesting features that communicate the material. For example, the thumb grip resembles a stream of flowing liquid, the coffee, as well as the grip on the palm are indents that look like coconuts, resembling the husk fibers used. The cup features a comfortable universal grip that molds and fits snug in the user's hands, with indents on the palm of the cup for increased grip.
The resin that was used is the AMT Solutions Material 1 resin. This resin was designated for the prototyping as it is an organic composite material that consists of a mineral crystal base and a water-based acrylic resin. This resin has beneficial characteristics such as low shrinkage during curing, resistance to chemical and ultraviolet degradation, and an excellent weight-to-strength ratio. The resin also lends itself particularly well to the use in combination with filler material. The resin surface is coated with Material 1 Sealer, which is an acrylic coating that improves impact resistance, surface quality, and resistance to water.
The next material used was a coconut husks. Its characteristics proved to be beneficial for the final product because it is lightweight, it is cost-effective, coming in at around 125 Rand per kilo, it is widely available because it is being sold at the majority of retail garden centers in bulk, it adds a natural visual texture to the resin, and finally it is also acting as a reinforcement for the resin. The fibers are strong and durable and would be able to increase the final product's damage resistance. The coffee grounds are also a natural byproduct that has been estimated to have yearly around 18 million tons ending up in landfills. In the Cape Town Central City Improvement District alone, there is 174 coffee shops. Using this in the resin would reduce the amount of coffee grounds being wasted, as well as reduce the amount of resin needed for each cast. This would in turn reduce the final manufacturing cost of each product. The bug-repellent characteristics of these coffee grounds would also make the material ideal for indoor use.
The first test cast focused on testing the casting properties of the coconut husk mixed with the resin. The findings of this cast showed the need for more husk to improve the strength properties of the material, as well as shorter husk fibers to improve the spread of the fibers throughout the mold. The prototype material proved to be brittle, but still held its shape, allowing for good workability regarding sanding and cutting.
Here is the positive we made on the final design. It is made from air-dry clay. It is molded around a metal insert. It has extrusions with grooves to give more insulation for the liquid to keep it hot or cold depending on the user's needs, and also giving more room for the inserts to be made.
The molding process started off with a bucket and some clay built up on the sides to make sure that we had a smaller volume of silicone that was being used to mold the cup. We dropped our positive within the cup and propped it up so it was centered, and then we started to mix some silicone. The silicone that we used was Moldstar 16. We chose the silicone because it has a very fast set time of 30 minutes. So this way we could quickly produce one or more molds within a very fast pace. The silicone as well didn't have a lot of compression, so that we could really compact the fibers, the coconut fibers and the coffee within the resin, and have it fill up all the spaces without expanding too much and deforming the overall end shape. So once we were done mixing that Moldstar 16, we then just poured it into the cavity between the mold and the positive and waited about 30 minutes for it to harden. And once it was hardened, we could take the positive back out and we had a clean, brand new mold to use.
The set mixing ratio for the mold casts was measured in weight, in the ratio of 1 part material 1 part A, 2 parts material 1 part B, 1 part coconut husk and 1 part coffee grounds. This would help achieve the attempted desired material characteristics of being less brittle, more impact resistant, insect repellent, more aesthetically pleasing, and a reduced volume of resin used in manufacturing the material.
So we let the biomaterial sit within the mold for about 48 hours, and we decided to finally take it out because we thought after 48 hours it surely must be properly cured. Turns out it was not properly cured. We took it out of the mold and it completely fell apart. Most of the bioresin was not fully cured at all, so it was quite a bit of a sludge and a bit of a crumble. There was quite big air pockets. That was probably due to us trying to shove the aluminium sleeve into the biomaterial, so basically squishing it up and out to fill up all the gaps, and that obviously led to quite a big air pocket within it, and as well was inconsistent material because when we put in the aluminium cup it got more closer to one side of the mold than the other, so some of the material was more on one side than the other, and obviously that in the final product that did not do. It should be consistent around the whole cup. Casting cup results. So what we had was a plastic cup that we put our biomaterial within, and we had a metal insert to create the cavity. So at the end of the day we had a biomaterial cup. What we found with this mold is that it had a more suitable mold geometry. It held up a lot better. The material consistency was much better as well. Wall thickness around the whole cup was all quite equal to each other. There was no thin walls or too thick walls, so it was all very consistent. There was fewer air pockets. There was tiny air pockets, but nothing to overall impact the structural integrity of the cup itself. And as well, better evaporation of moisture, so our bioresin cured much faster and actually cured compared to the first casting. So all in all, this was a much more effective method. Possible uses would be limited use cups, decomposable plant potting, and composting soil coverage.
There are a few possible causes for not achieving the desired material in these casts. Solutions to these would be further dehydrating the coffee grounds and using a finer ground granules, lessening the ratio of coffee grounds in the mixture, curing in a more temperate and controlled environment, and allowing the casts a longer curing time. For further development of the material and in an attempt to better achieve the desired properties, an adapted mixing ratio was developed. This consisted of 1 part material 1A, 2 parts material 1B, 0.25 parts coconut husk, and 0.25 part coffee grounds. 3 sample casts were made using this mixture. Cast A was a simple pour cast as per the ratios. This delivered a promising material with valuable material properties. Cast B was a pour cast with an applied pressure during the curing process. This, however, didn't lead to any observable differences compared to cast A. Cast C was conducted by pre-positioning the husk in the mold shape and then pouring resin over the husk. This allowed for denser and more evenly spread husk placement. The use of sealer was then tested on these casts. The sealer complements the material and gives a desirable surface finish. The sealer especially complements the live edge texture that was achieved, resulting in an interesting natural surface.
To conclude the biomaterial project, we would like to state that the biomaterial was a success, and we believe it to have a vast amount of applications beyond what we have stated. We all learned a considerable amount of new information and skills that we can apply to the next batch projects in the future.